Okay, new problem. We've got an engineer who wants to determine how the weight of a car affects gas mileage. The following data represents weights of various cars and their miles per gallon. Okay, so let's open this in StatCrunch. First thing we're going to do, just as before, is we're going to find the linear, the least squares regression line. So that'll be the first task. And what is going to be involved in that is the exact same procedure. We just go to the regression menu. Okay. I'm going to, again, move it. Go to Stat. Regression, simple linear. Now, this time we're going to determine how the weight of the car is X. Oh, it's labeled with X right there. That's great. The miles per gallon, Y. Okay, let's click compute and just see what we get. The least squares regression line is given to us. So we've got our intercept and our slope. The slope is negative 0.0039, rounds up to 4. And then the intercept is this 34.2045. I again have to round it up. Okay, great. We're going to now do a little bit of interpretation. What is the slope and intercept? So the slope is, since the weight of the car is pounds, the slope is saying, okay, if we increase the pounds of the weight of the car by a single pound, we expect on average that the miles per gallon will decrease by 0.004 miles per gallon. So the slope indicates the mean change or average change in miles per gallon for an increase in 1 pound in weight. That's the interpretation we give for the slope. The best interpretation for the y-intercept, it doesn't. So if x equals 0, then the miles per gallon would be the y-intercept, 34.2044. But what does that mean? A car that weighs 0 pounds? That's not realistic. In some problems, the y-intercept has a realistic interpretation. Sometimes it doesn't. This is a situation where it's not appropriate to interpret the y-intercept. It doesn't make sense to talk about a car that weighs 0 pounds. Okay, now let's talk about prediction. To do a prediction, we can actually just plug numbers into a calculator, but I'm going to show you how you can do it in StatCrunch. So let's go back over to our stat output and hit edit. Here I'm going to scroll down a little bit. A prediction value of y, I'm going to click here and type in a prediction, an x value. So let's predict the miles per gallon of a car B. For car B, we had 3095. And what I'm going to do is see what the predicted value would be. So I'm going to click compute. And in my statistical output now, there's going to be a little bit extra, which is right down here. You can see for an x value of 3095, the predicted value of y would be 21.87817. That's great. So I'm going to put just into 2 decimal places. 21.887 would be 88 rounded up because of that 878. So now the residual. The residual is the actual value minus the predicted value. But you know what? I'm too lazy to calculate residuals myself. Click edit again, and I'm going to go scroll down in this, and there's an option down below for me to save residuals. I'm going to, and even model estimates. That's even faster. Model estimates and residuals. I'm going to click compute. I'll show you both of those things. Model estimates, predicted values, and residuals. Look at that. Isn't that cute? If you look here now for car A, it tells you what the residual is. It tells you the predicted value. For car B, the residual, the predicted value. It gives you all of those. So actually, we're looking at car B, the residual, and the predicted value. I could have done that right away, but that's all right. The residual for for car B is negative 1.178, rounds up to 1/8. So since the residual is negative, you can even see that from the graph for car B, which is the it's hard to tell because these aren't labeled, but they are in increasing order. So car B is the second dot. It is below the line. That means that this car is below average for its miles per gallon. At least as far as this model is concerned, it's below average. A negative residual means below average. Okay. Oh, and look at that part. The last part of the problem is asking us to do the least squares regression line, which I happen to already have pulled up. So, and label the residuals. Oh, it looks like it's, just looking at the graph, I'm going to magnify here. I think this is it. This looks like, you can see the points are all scattered around. This is point car B. This is what was predicted. This red line, that distance, in fact, the difference, it's negative, is the residual. So that is, yep, that's certainly our answer. Great.